Welcome back. This is video number 4. I'm going to introduce sorting algorithms. To sort simply means to arrange values into a particular order, whether ascending or descending. Notice that at this point we're talking about arrays, so just settle in. Excuse me. There are two algorithms we're going to look at. The first one is selection sort. And the basic idea of selection sort is if you have a stack of papers with grades on them, it's kind of normal to find the highest grade in the stack of papers, put it on the table. Then go back through the remaining papers, find the highest out of those, put them on the table, and so on. And each time you find the biggest value, you're placing the biggest value in its proper place, and you are not considering those sorted values anymore. You're not going to handle them anymore. Similarly, we can take the smallest value and lay it on the table face down. Smallest value, the remaining, put it on the table face down. So at the heart of the selection algorithm is being able to locate where the smallest or the largest value is and taking it and placing it where it belongs. And we'll show you how to do that momentarily. So here goes. So again, here's the algorithm. Locate the smallest element. And we look at the whole array in the beginning from position 0 to the last subscript and find out the subscript of the smallest element and swap where the smallest element is with the first element in the array, thereby placing the smallest element in the first element of the array. You can continue to do that. Notice that you have to go through the array many times, each time looking for the smallest value. Going through the array one time just to get one value in position is called making a pass. So if I have n elements within the array, to perform this sort I need to do n minus 1 passes. All right. Notice that the selection sort can be based upon the smallest element or it can be based upon the largest element. The idea is the same. Here's the example. If I have a list that has 11, 2, 29, and 3, on the first pass I locate the position of the smallest element, which is 2, and I say, aha, 2 belongs in the first position where the 11 is. So I simply will swap the 2 and the 11 so that as a result I will have 2. I have colored it red because now 2 is in the right place. And the next step in the sort will treat only these values here. So on the next step, 2 is in order, and I will apply the same process of finding where the smallest one is. In this case, the smallest one is here. What do? We swap. Where does the smallest one belong? The smallest one belongs here. So we're going to put the smallest value into its rightful place. So we will swap or exchange 3 and 11. So after that, we will have this, and so forth. All right? A thing to note about these algorithms, after one pass, one element is in place. After 2 passes, 2 elements are in place. After 3 passes, 3 elements are in place. All right? Is that clear? All right. Now, selection sort. In my mind, the selection sort is the simplest algorithm because the only time you flip things is when you find the smallest or the largest and put it in its rightful place. And doing this kind of matches how you would do a stack of cards or a set of papers. Here are some properties of the selection sort. It requires a nested loop. One loop is really concerned with making sure you do all the passes that you need to do. And so you should have a variable called pass, and you can number your passes however you want. In this case, it's convenient to number the passes starting at 0. And I want to go from 0 to n to less than n minus 1. Right? And the inner loop really goes through and finds the position of the smallest value within the subscripts from whatever the pass is to n minus 1. All right? And we really need two functions. We need a function that will swap, and we need a function that will take an array from subscript low to subscript high and tell you which subscript, the subscript of the smallest value in that array. And the algorithm becomes very simple. You go passes, and think of it this way. On the first pass, I'm filling sub 0 position. Second pass, I'm filling sub 1. The last pass, I'm filling sub n minus 2. But when I fill the next to the last element position, I have completed the sort. Say it a different way. If you start off with two elements, if you just do one swap of two elements, you will one swap of two elements, you will have the array sorted. So the algorithm is pretty simple. You call these functions position, min, and swap, and you do it for all the passes that you need to do, and that's the algorithm. Okay. Now here's the selection sort exercise. You completed the binary search test binary search program. Now I want you to take the same program and convert it to test selection sort. And you want to write the function for selection sort and test that it works. Now your main program now has to print out the array before and after sorting. If you want to, you can use the same array that you have in the binary search array. You may want to take the numbers and change them around so that the array is not sorted every time. Okay? And we will stop.